Good morning, friends. Today we have discussed about hydraulic and pneumatics, unit number 3, fluid power control. So, direction control valve. Today we are discussing. In this session, student will understand 4 by 2, 5 by 2 direction control valve. In previous lecture, we have seen 2 by 2 and 3 by 2 direction control valve. Today, we have discussed 4 by 2 and 5 by 2 direction control valve, different types of valve, center, and their applications. Rotary type spool valve. So, learning objective. At the end of session, student can understand 4 by 2, 5 by 2 direction control valve and their application. Different types of valve, center, and their application. Rotary type spool valve. 4 by 2 DCV. Important feature. 4 by 2 means 4 port, 2 position. P port, T port, A port, B port. 2 position means null position and active position. So see here, P port, T port, A port, B port, P port, A port, B port, T port. See, this is null position, this is active position. See, like that. So see here, this is 4 by 2 DCV direction control valve. 4 position, sorry, 4 port, 2 position, 4 by 2. See, this is 2 position here. So, valve body, A port, B port, P port, T port. So, this is position A to T and P to P. This is pump, tank. In this way, liquid going to P to B and A to T. Here, valve body, liquid going to P to A and B to T, P to A and B to T. In this way, our symbolical representation like that. This is 4 by 2 position, 4 by 2 DCV. So important features. Important feature, application of 4 by 2 DCV, retract and extended the position of DAC. Retract and extended the position of DAC. So, piston is retracting. So, see here, pump suck the oil from the tank. Oil going to P to B position in this direction. Then pressure apply on this piston by backside. And from here, oil is removing, going to the tank like that. This is piston is retracting. Piston is extending. So oil going to the piston side and piston backside oil return to the tank. So piston extending. In this way, we have applied 4 by 2 DCV direction control valve. This is pressure relief valve here. This is pressure relief valve. 4 by 2 DC to control bidirectional motor. See, in this way, P to B supply here bidirectional motor, and here oil remains to tank, coming to tank like that. Here like that. At second position, oil supply P to A and return to B to T. Here oil supply P to B. Here oil supply A to T. Return to A to T like that. Can you identify the differences? See here and see here. This is 5/2. This is 4/2 because 4 ports. Here 5 ports. See here, port P1, P port, 1 tank port, 2 actuator port, A and B. 1 P port, exhaust port E and E. Actuator port A and B. So valve position, 2 position null and activate. 2 position null and activate. Grid 4/2 DCV found in hydraulic, 4/2 DCV found in pneumatic. This is 4/2 DCV. This is found in pneumatic. 2 exhaust port, 1 port is extra here in 4/2. This is used in pneumatic. So 4/2 hydraulic valve. In hydraulic valve, the tank ports are combined within the valve body into one common part. A pneumatic valve, the return flow for each outlet is exhaust to a separate port. Air is vented to atmosphere, does not add any extra lines. But in hydraulic, if we provide 2 separate return lines to tank, it required separate piping and fitting, which may leak and result in pressure drop. Notice that the 4-way pneumatic valve actually has 5 ports. It is still called a 4-way valve because the exhaust ports are considered to have the same function. Application used to control double acting air cylinder. See 4/2 hydraulic valve. 4/2 hydraulic valve, we can see here. Notice that 4-way pneumatic valve actually has 5 ports. It is still called 4-way valve because the exhaust ports are considered to have the same function used to control double acting air cylinder. Can you identify the difference? How many ports and how many positions? Yes. See here, port 1P port, exhaust port. This is symbols. See, this is our regular port, A to E, B to P, and this is closed port. This is second position. But here, we can see like that. So P1 is the P port, exhaust port, actuator port A and B. In here, 1 P port, exhaust port 3 and 5, exhaust port 3 and 5, actuator port 2 and 4, pivot signal 12 and 14. From port 1, exhaust port 3 and 5. Okay. 2 position null activated, 2 position and null activated. 4/2 DCV found in pneumatic, 5/2 DCV found in pneumatic. This is 4/2, but this is 5/2 because 2 pivoted signals 12 and 14. like that. 5y2 DCB direction. 5y2 direction control valve, double pilot valve. It is known as memory valve, referring to the figure. A pneumatic signal is at pilot port 12 causes the spool to switch over as shown. In this position, fluid path from 1 to 2 and from 4 to 5 are open. Exhaust port 3 is closed. The valve remain in that position even if the signal at port 12 is removed. If a signal is applied at pilot port 14, the spool switches over as shown. In this position, fluid flow path from 1 to 4 and from 4 to 3 are open and exhaust port 5 is blocked. The valve remain in this position even if the signal at port 14 is removed. Hence, it can be observed that 5x2 double pilot valve is two position valve that remains in one position until a pulse and continuous signal is applied in the opposite position. Valve body, spool, valve body. It is also known as memory valve. So it is signal applied to pilot port 14. The spool switches over as shown in this position to its flow path 1 to 4 and from 2 to 3 are open and exhaust port 5 is blocked. The valve remains in this position even if the signal at port 14 is removed. Hence, it can be observed that 5x2 double pilot valve is two position valve that remain in one position until pulse and continuous signal is applied to the position direction. Single conflict. A major problem with the memory valve is its inability to change the switching position when pilot signal appears simultaneously at both pilot ports of the valve. This signal produces equal and opposite forces on the valve spool, and hence the latter tend to remain stationary until one of the signal does off. This problem is called signal conflict signal or ray, which is major hurdle in multiple cylinder circuit. Various methods have been devised to overcome the problem of signal conflict. The following valve modulus may be used for the purpose of avoiding signal conflict: ideal return roller, reversing valve, modular as combined valve. This is valve body. See, signal applied to the port, applied to the port number 14. Like that, we can see 1, 2, 3, 4, 5. Signal applied to port 14. See here, this is symbol. Different types of valve center. Different types of valve center. See here, limitation of 4x2 DCV. What happened to linear and rotary actuator? Piston is extending. This is oil supply by pump to the position A, P to A in this way and return to the tank. Here, oil supply in this way, like that, to bidirectional motor. I return to the tank. Valve center, valve neutral, cross center, open center. See symbol of cross center, cross neutral. This is open position, this is close position, this is cross section, cross position. This is open center. Valve is open at center. tandem center, tandem center, growth center, regenerative center, regenerative center. See, this is very important. Wall neutral and wall center position. See, this is closed center, this is open center, this is tandem center, this is broad center, and this is regenerative, connected to tank, outlet of the actuator port connected to outlet tank. Then this is broad center and pump supply to both port actuator. Then this is regenerative center. In this way, we have used closed center, BOA, port B, A, port P, spring, spool, T, T, closed center, closed neutral, PT, A and B. Four by three DCV with closed neutral, DAC rod. DAC 4 by 3 DCV with closed neutral. Observe what happens to pump and actuator is center position. Sorry. See here 4 by 3 DCV with closed neutral, closed center 4 by 3 DCV. Here pump supply to rod, oil supply to the means extending the pistons. So to rightward means rod as constant position. This is observed means at some distance we have stopped this process. After that, piston retract and their pressure build up. Pistons retract and their pressure build up. Piston extend and their pressure build up like that. Pressure relief is must at pump outlet. See, this is return pressure coming in this way. For removing pressure or for maintain the pressure release position. Pressure relief is very important. Open center. See, this is open center. Spool, bore, open center. Right. 4/3 DCV with open center. 4/3 DCV with open center. Tandem center. C, tandem center, both port A and B is closed. Application of tandem center we can see here, like that. Float center also we can see here. 4/3 DCV with float center we can see here. Regenerative center is a general term used to describe a system in which the waste is fed back into the system to supplement in the input power. Example, a turbocharger takes the exhaust gas from an automobile engine and uses its energy to turn a compressor. Compressor then feed pressurized air into the engine, giving in boost in powder. 4/3 DCV with regenerative center. It is in the regenerative neutral. Instead of sending the return flow back to the tank, it sends it to the inside of the cylinder, thereby increasing its speed. We know that the general equation for velocity of an actuator Q equal to area into volume. So area into velocity. So velocity equal to Q by A. So at neutral, return flow is being regenerated. Now the total flow to the head and side of an actuator is pump flow plus the flow coming from the rod end. The above equation is known as VE equal to QP plus QR upon AP. In this way. So same for 4/3 with regenerative center. The flow of the rod in given QR equal to AP minus AR upon VE. So with regenerative, substituting the equation VE equal to QP plus QR upon AP. In this way, we have find out VE equal to Q plus AP minus AR upon VE upon AP. So QP equal to AR VE. So VE equal to QP upon AR. Force available when the system is regenerative modes. So regenerative PAP minus P into AP minus AR. Regenerative PAP minus PAP plus PAR. Regenerative equal to P into AR. 5 types of centers and neutral. We can see closed, tandem, float, open, regenerative. PVR is must and hinge pump flow through the PRV in closed. Effect of the actuator holds position. Tandem pump flow through DCV of the tank. Holder position. Float. PRV is must and hinge pump flow through PRV. Open pump flow through DCV to tank. Regenerative pump flow to cylinder. Rotary spool valve consists of a rotary spool which align with hole in the wall casting give the required operation. Simple, compact, have low operating position forces, low pressure device, and hinge used in hand operation in pneumatic system. Disadvantage due to rotary motion of spool, leakage inside this valve is possible, not suitable for high pressure. They are generally manually operated. See, we can see our heart. This is stationary casing, rotary. P and B port, A port, R port. Rotary spool wire and threading spool wire, we can see here, like that. Rotary type direction control wire. In this way, we have to control the direction of rotary spool wire. Any doubt, any queries, please ask me. So today we have stopped here. Thank you.